Level 1. Level 1. Level 1. Okay. Am I loud and clear? Let's see. Okay. Just give me 2 minutes. To me. So we are live. It's fine. Okay. Let's wait for 5 minutes and then we are good to go. Okay. Okay. Good evening, everyone. Welcome back again to Analytics with Anand. So today's we'll be talking about your lecture number 41 of mastering Snowflake. Right. So here we'll be discussing a very, very important concept of how do we handle semi-structured data. Already about semi-structured data we have seen in lecture number 39, where I have discussed with you how you can parse your JSON file, how you can parse your nested JSON file. And in lecture number 40, we have seen how to parse a nested XML file. These two are very, very important from your interview point of view, from your career point of view. When you will be working in a company, you will be interacting with all these kinds of data sets. So lecture number 34, as I keep repeating, this will help you give you a roadmap, give you a base foundation, how you can copy, how you can bring the data from one source environment, be it AWS, and put it in your target warehouse, which is Snowflake. Then lecture number 35, which talks about how you can do the same thing with respect to Microsoft Azure, right? These two are with respect to CSV. Lecture number 39 is for JSON, and lecture number 40 is for your XML. And this is the lecture number 41, which we are going to discuss. How do we handle optimized row columnar data, ORC data format in Snowflake? Now, we all are aware what are the type of data types which we have it in Snowflake. Anyone in the audience? What are the type of data types which Snowflake supports? Can someone mention in the chat? What are the different kinds of data type which you think Snowflake supports? And first of all, why do we need these kind of data sets? Why do we need these kinds of data format, right? Because when you see the data is generating a tremendous amount on a daily basis. You have data generating from IoT devices. You have data generating from sensors, from ETL tools. Multiple sources are there. Now, these data can be in different varied format. So that's why Snowflake has the capability. Snowflake gives you that scenario where you can able to handle all these data, be it your structured data, semi-structured data, or be it your PDF file, text file, CSV file, right? Or your JSON file, XML file, ORC file, Parquet file. All these Snowflake supports. Now in today's class, we will discuss about ORC. Very, very important concepts which will really help you. The foundation will remain the same. Your lecture number 34, lecture number 39, and lecture number 40 of the playlist. So if you have not subscribed to still the channel, Analytics with Anand, go ahead and subscribe. And thanks to each one of you for making it a great 16K follower. Now we have, right? Due to office work and all those things, I couldn't come online here, but I'll make sure whatever things are done here, that will really, really help you in cracking down any interview. So anytime when you go in an interview and interviewer asks you, do you have understanding working with different data sets? Tell them, yes, I do have understanding how to handle structured data, how to handle semi-structured data. Lecture number 34, 35, 39, 40, and 41 will be your keychain for all of this. Okay, so before wasting any time, let's get it started. I'll share my screen, and this is very, very important, right? This will be a very short session. It's very easy. Those who have watched my lecture number 34, 35, 39, 40, it will be very, very easy for you. Okay, it's very, very easy for you. So just focus. You don't have to do along with me. Just focus, and I'll take care from here. Okay, later on you can practice it. So let me share my screen quickly. Share screen. Here you go. Yes. Let me know if my screen is visible. Okay. Yeah. Is it visible for you all? Yes, no? Can you see the screen? Yeah. I think you can. Yeah. Okay. Yes. So what is this ORC? Now, listen very carefully. Whenever client will be sharing you the data, client will share you the data from an external environment. It can be from the Oracle, it can be AWS, it can be Google Cloud, it can be Microsoft Azure. Now, what is the beauty of this cloud environment? As I keep saying in all my class, pay as you go format. Now, imagine if you have a data in the form of CSV, which is taking like 230 MB, 450 MB, and AWS and Azure and Google Cloud, all these are on pay-as-you-go platform, right? So more the number of size, if you increase the size of the S3 bucket, if you increase the size of the blob storage, you have to pay that cost, right? Now, whenever this data will come into in the form of S3 bucket from your AWS or blob storage in the form of Microsoft Azure, these data will be highly, highly compressed. I will give a very realistic example. You all share your document. Whenever it's a joining day for you in any company, or whenever company wants to give you any offer letter, they ask you PAN card, Aadhaar card, 10th mark sheet, 12th mark sheet, all this. Can you dump all this? Can you attach all this as an email? No. Email support max to max 25 MB. It becomes very, very difficult. So what you do, you collate all the document and you zip it. Zip is nothing but you're compressing the file in the form of zip format, right? And your entire 25 MB data comes down to what? 5 MB data, which is very easy to share. So anyone can unzip it. Similar fashion, we as an industry, we as a data analytics industry, data engineering industry works. Anytime you get a data from the external environment, and that will be in compressed format. And Snowflake has the capability to uncompress it, and you can create tables or view, and you have their use case, right? So Snowflake has a wide variety support for big data. It's an ideal platform for executing big data workloads. This terminology is very, very important. Big data workloads using a variety of file formats, Parquet, AVRO, and XML, right? Today class, we will be discussing ORC. In few class, we'll see how to access AVRO also. XML already I have done. Lecture number 39, CSV structured data we have done. Enormous session, lecture number 34 is there. So Snowflake makes it very, very easy to ingest semi-structured data. Now, what are these data sources? JSON, XML, AVRO, Parquet, ORC, all these are semi-structured data. That means data are not in a proper structural format. So we need to extract that information. That is very, very important. Right. So with Snowflake, you can specify compression schemes for each column of data with the option to add additional encoding at any time. So Snowflake gives you all this flexibility. So you can create and run modern integrated data applications, democratize data analytics to team members of all skills level, can make data-driven decisions and develop new revenue streams based on data to help drive your business forward. So Snowflake makes it possible to realize the full potential of the data with the flexibility to choose which file format best meets your need. So anytime when you start working in any company, be as a data analyst, data engineer, senior business analyst, senior business data analyst, senior data engineer, lead data engineer, data scientist, anything, the first question which you need to ask your business consultant, or the stakeholder, what is the kind of data are we targeting here? What is the kind of business operations which we are dealing with? What is the frequency of the data, and what kind of data do we see on an everyday basis? So today's class, we will be focusing one of the most important semi-structured data, which is nothing but your ORC. We have other data set also: JSON, lecture number 39, AVRO, XML, lecture number 40, Parquet, and ORC. So ORC, first of all, let's understand first of all how about ORC. What does it stand? And then we'll see the real application in the Snowflake. It's very easy. Nothing you have to do it. I'll take you straight away. So ORC stands for Optimized Row Columnar File. Optimized row columnar file. It's a data storage format, right? It's a data storage format designed for Hadoop and other big data processing system. Whenever you have a huge chunks of terabytes of data which is flowing, getting ingested in your system. So these are designed. There are certain compression method which has been designed for Hadoop and other big data processing system. So it is a columnar storage format, same as Snowflake. Snowflake also stores data in a columnar format, right? Which means data is stored in a way that is optimized for a column-based operation like filtering and aggregation. It will be stored in a column base for filtering and aggregation. You can see this, right? Here you can see a stripe, right? 250 MB stripe, 250 MB stripe, 250 MB stripe. What is the beauty of Snowflake? Snowflake stores data in the form of micro partition file. Each file size is of 16 MB. In the similar fashion, ORC is also compressed, which will be stored in the form of stripe, where you will be having index data, you'll be having stripe footer, row data, and index data, and everything will be corresponding to column wise. It stores data your column wise. Let's go into complete detail. So internally, ORC stores data in a series of stripe. What is the stripe? Stripe is nothing but a collection of rows. Stripe is nothing but a collection of rows. This, you see this stripe? These are collection of rows. Okay. These are collection of rows. Each stripe is further divided into a series of data chunks where each chunk stores the data for a specific set of columns. These chunks are compressed using a combination of techniques such as predicate filtering, dictionary encoding, and run length encoding. You don't have to go into this complete detail how this is being compressed. You just have to understand how does my ORC data look like and how do I extract meaningful information from the ORC file whenever I'll be receiving from the client. So ORC will also stores metadata. Now, the beauty of this Snowflake is Snowflake stores your metadata. So Snowflake knows when the new data has to get ingested or when the data which has already been ingested, that I don't have to process it further. So ORC also stores metadata about the file, such as schema at the end of the file. This metadata is used to quickly read the data without having to scan the entire file. Additionally, ORC can store indexes for specific column, allowing for faster retrieval of specific rows. Now, this ORC file comes really, really handy when you have the data retrieval process. Suppose you have 2 terabytes of data, which is getting ingested in system, and you need the faster retrieval for specific number of rows, then your ORC will come very, very handy. So one of the main advantage of using ORC file is that they offer significant performance improvement over row-based storage format like text and AVRO. This is because in a columnar storage format, the data for a single column is stored together. Data for a single column is stored together, which makes it faster to read and process. So anytime the situation is like you have to read very frequently, ORC is the best file format at that particular moment. So additionally, ORC files also support advanced features such as predicate pushdown. You don't have to go into complete detail what is predicate pushdown and all those things, which allows the storage format to filter out unnecessary data before it is ready to memory, further improving performance. This is how inbuilt it has been designed. So ORC files can also offer good support for compression. It uses a number of compression algorithms, right? Now, whenever you see, when you have a zip compression format, you have Snappy, you have a zlib, zzip, etc. Now, how these compression techniques work, that is not the agenda for us today. That we don't have to go into that detail, which reduce the storage space required. So if you are storing a CSV file, which is 250 MB, now if you have an ORC file, the same 250 MB file will come to 47 MB, right? 250 KB will come to 47 KB. That's the beauty of this ORC file. You guessed, this is particularly useful when working with large data set, as it can significantly reduce the cost of storing the data, because Snowflake because AWS will charge you based on the storage. If you are using 2 TB of storage, it will get charged you. So imagine when a company has some 10,000 files, 1 lakh of files, and if every file is of 250 MB, 200 MB, 300 MB, if you don't compress it in the right compression algorithm, be it AVRO, be it Parquet, be it JSON, or be it though it doesn't make any sense. It will add cost. It will add cost. That's why we have all these compression techniques. So another advantage of overseas file that they support a wide range of data types, including complex types such as structure, maps, array. So this makes it easier to work with different kinds of data and allows for more flexible data marking. How you can read it in PySpark and Python, which I'll be teaching you. So spark.read format ORC. Snowflake, it's very, very simple. Just the one keyword, create or replace file format. File format equals to ORC, and you will be able to see it here. It's very clearly forward. Create or replace file format name, type equals to ORC. Just you need to specify this and things will work from here. Just you need to specify this. File format name, and type you have to give to ORC. That's pretty straightforward, right? So it's widely used in the data analytics industry. It has an efficient storage. I keep talking about, right? It has efficient compression techniques, which is making it very cost effective. This is beneficial when you work with large data sets, which reduces storage requirement and speed up query performance, right? Correct. Why it is faster? Because it stores the data in columnar format. Entire column is stored all at once. That only require a few columns can read just those columns, reducing the amount of data that needs to be risked from disk. Indexing, very, very important. Suppose you are reading a book, you want to go to a certain chapter. What, you will go page by page? No, you have an index. You will go to the first page, see the index page number 176. You will flip to the page number 176. That's the beauty of indexing. So ORC files automatically include lightweight index, min, max, and sum for each column, which allows for faster query processing by skipping unnecessary data blocks. It is integration with big data tools. So it is natively supported by Apache Hive and Apache Spark, two popular big data processing framework. This allows for seamless integration and efficient processing of ORC file within this ecosystem. Then comes your data lake storage. It is often used in data lake where you have a large volume of raw data which are stored and processed. So their efficient storage and retrieval capabilities make them ideal for such environment. Then comes your scalability. ORC files are designed to handle petabytes of data. I told you, terabytes, petabytes of data, making this suitable for large-scale data analytics tasks. Their structure supports the parallel processing capabilities of modern distribution system, right? So, and it is used in any pipeline, any ETL pipeline, you name it, are frequently used in extract, transform, beat, Matillion, beat, Informatica, beat, Alteryx, right? To store intermediate and final data sets. Their compatibility with business intelligence tools enable efficient data analysis and reporting. So in summary, ORC files are favored in the data analytics industry for their ability to efficiently store, compress, and quickly retrieve large data sets, making them essential in big data processing and analysis environment. So it is generated from various data sources. You can be generated from Apache Hive, Apache Spark, data warehousing and ETL tools, Presto and Trino. Presto is a SQL engine which generates this ORC files, right? Apache Pig, it generates an ORC files. All your custom scripts and application, right? By Hadoop, Spark, Hive, correct, Java, Python, Scala that uses library like all this can create ORC files directly, right? You have a data conversion tools when you are migrating, right? So these utilities are often useful when migrating data to ORC. Right. So here I've given a distinguish between when to choose ORC or Parquet. So ORC is optimized for read heavy workload. When you have a frequent data retrieval, when you want to retrieve data on a very frequently basis, right? Then you will go with the ORC and it can perform query performance, right? I want to do. So if your use case requires a lot of read heavy workload and you are working with large data sets, then ORC is a better choice. Now, if you are doing a mode of writing purpose, when I'll teach you separately Parquet, then Parquet will come into the picture, right? Client goes with both. In my previous company, mostly all the files were Parquet because we were used to do a very heavy write operation. We want to use a very much transformation. Just for the reading purpose, ORC is the one. Just for writing purpose, Parquet is the one, right? So use predicate push down to optimize filter operation and you do use data, use bucketing, right, to group similar data together for faster query processing, use compression to reduce data storage costs and improve read processing, right? All this information, caching to store frequently accessed data in memory for faster query performance. So these are all the different features. So ORC file format, it's an efficient format for big data processing system, which we use due to its columnar nature, predicate push down, data compression, and support wide range of data. So this is the link which I have referred, which you can go and entire Snowflake has given, which is better, right? faster analytic workload, splittable file format, everything it has discussed about difference between AVRO, Parquet, ORC, and all those things, which you can read it from here. Link I have given already in the documentation. Go through it, just understand what it is, how it is stored. Right, this image is very, very important for you. It is stored in the form of stripes, where you have all the indexing is there. So due to this, your data retrieval works very, very faster. Understand indexing from the point of view that same how your any textbook, if you are reading, how you have an index, so it becomes easier. And how many stripes it has? 250 MB stripe. Each stripe is of 250 MB, and it has multiple columns, column 1 to 8, column 1 to 8, having multiple rows embedded in it, just like how the Snowflake architecture has been designed in the similar fashion. So this is all about the theoretical aspect of ORC. Now let's see the practical implementation. Without practical, nothing works in the data analytics industry. So quickly, I log into my, by the way, resource for all this I have shared already in the lecture number. If you go to the Snowflake branch of my Analytics with Anand GitHub, lecture number 41, there's a folder, entire thing, PPT, whatever I have discussed, PDF, everything is there in lecture number 41. All the files, SQL script, everything I have given you, which you can find in the description from this video. Okay, which you can find in the description of this video. Now coming back to this ORC data, let's come here. So first of all, what you will do? First of all, let's go back to my AWS console. And let's see what is the bucket. First of all, you need an S3 bucket for this, right? First of all, you need an S3 bucket for this. Come on. Yeah. First of all, we need an S3 bucket in order to store the files. So what I've created a bucket already, right? I'm existing bucket only. I have created ORC parser. Can you see one folder called ORC parser? Inside this, I will be pushing all this data. First, I'm deleting all this, so that you can see in reality how things works. It's a very quick demo. It's very, very easy. If those who have watched lecture number 34, it will be very, very easy for them. Shall I have deleted? Yeah, nothing's there. Okay, let's come back. Yeah. So first of all, you need a database. I'm not creating a database because I already have a database. I'll be using demo database, and I'll be using demo schema. Compute warehouse, I'm using it large. You can use it medium also, right? So first of all, you can create a database. I have an existing database, demo database. I'll be using that. So first of all, now, whenever you are storing all this data, what is the by default data type? What is the by default data type of all this semi-structured data? How do you store the semi-structured data? You store in the form of data type called variant. You store something in the form of data type called variant, right? Called variant. Remember this. You will store the data type in the form of variant. So I'm creating a table called sample ORC, and I'm creating a column called source variant. Data type will always be variant, be it AVRO, be it Parquet, be it JSON, be it XML. In lecture number 40, also we have taken a data type as source as variant. So let's create this. Right. Let's create this. I'll come back to this table later on. Now, once you have a table, why we are creating a table? So that the raw data which we will be putting in the AWS, that we're gonna ingest it directly. Then we should be having file format, because Snowflake is not that smart enough. Until unless you specify the file format, Snowflake won't be able to get to know. So I'll create a file format, ORCFF, ORC file format, type equals to ORC. Let me run that. Correct. So demo database, you can see all the file format has been created. Correct. ORCFF. Next. Now what we'll have, we'll create something called storage integration. As I keep repeating, we will create a setup. We will create a pipeline between my AWS S3 bucket and between my Snowflake. So I'm creating a storage integration called S3 bank. I'm calling it as external stage. Storage provider, I'm giving it as an S3. Enabled is to ARN number, the role which will define the set of policies, right? Whether this particular user has the right set of privileges in order to access that particular folder or not. And which is the allowed location. Allowed location I'm giving is the root folder. So this is the stage I'm creating it. Right? Let's describe the stage and see it. So you can see this is the stage which has been done, right? User ARN. Now I keep telling whatever the user ARN, you got this, you have to update the trust relationship. Lecture number 34, I have discussed all this. Go back to your role and policy and check whether the trust relationship is properly populated or not. Identity and access management, you have to go and you have to see whether you have the right set of privileges in order to perform these operations. Banking role, trust relationship. Yes, it's updated. This has to be updated here in the trust analysis. Otherwise, you keep getting authentication error not found, right? Authentication error not found. So you'll keep getting this error. So make sure you have done this. So once you have stage get created, once you have stage got created, what is the next thing? What is the next thing? Next, we'll create one called stage. This is the storage integration. This is the linkage. This storage integration will tell whether you have the right set of privileges in order to access that particular bucket or not. Now, I will be creating something called stage. I won't be directly ingesting the data into my table, but it will be there in the stage. The same way, if someone comes to your door, he or she doesn't directly walk into your just room. He or she will go to the society gate. You will approve it. Then that particular person will come. So what I'm creating a stage. URL I have given, the URL of the S3 bucket, file format you have to specify, and storage integration name. You can also either URL or you can also specify the credentials, but this is not recommended. Until unless you have the AWS key ID and secret key, do not expose this. So let's create a stage called ORC demo stage. And we'll see, we'll list on the stage. Yeah, nothing, no file is there. No file is there, right? Let's see the stage. Yeah. So ORC demo stage, I have created it, right? It's an external, region is EU North 1, and it's an external S3 band. Next. Now I'll create a pipe. Now I will connect that particular respective folder with my table, Here I have connected a table. Here I have connected a table called, where is the table? A table called ORC test table. I'll show you how does the S3 data looks like. First of all, let me upload the first file here so that we can see how the data looks. Add files, downloads, here you. Yeah. The ORC parcel, we have the first data here coming, okay? Yes. So let's list down the stage. Bang on. First file has been ingested. So list, can you see this? First file has been ingested. First file has been ingested, right? First file has been ingested in the stage. First file. Now I won't be saving it in the table. First, I will query what exactly does this look like? What exactly does this look like? What is the file which is getting ingested? So we have a file called user data one ORC, last modified, right? Hash key is there, MD5. And then the size 47448. 47448. Now I can see what exactly in this particular data do we have. So this is the kind of data which you will expect. Yes. So this is the syntax which we follow. T dot $1. $1 is the column name. $1 is the column name from stage. I have not saved it yet. I have not saved it anywhere in the table. File format I have given, and I've given the alias as T. So if you click every row, you can see it is in the form of a semi-structured data type, which is none other than like it compressed in the form of ORC. Something looks like a JSON, right? This is the first name. This is the second name. Now you have to extract this. Now, there may be a requirement where you are designing a Power BI dashboard and you have some financial data. You have some KPI written here. Like column number 2 is the first name. Column number 3 is the second name. Column number 4 is the email ID. Column number 5 is the gender, right? All these things. And column number 11 is the designation. Suppose I want to retrieve all this information, right? I want to retrieve this information. So if I want to retrieve this information, what I will do? First of all, let's see whether data is there or not. Achha, no row is available. Let's create this table first. What I'm creating? First name, last name, email, gender, country, designation. Now, this requirement will come from the client. What exactly we need to store? So I will extract the first name, last name, email, gender, country, designation. Do not create this table until unless you have pulled the data from the stage. First, have a look of the data. Then based on that, design this particular table. Now, once this table gets deleted, I have my stage. So I will directly using Snowpipe features of Snowflake, I will directly ingest my data from the stage to this table. Automatically, whenever new things will come, new data will come, it will automatically get ingested, right? It will automatically get ingested. Let's see. Yeah, first data has been sent. First data has been sent. First data has been sent. Right, let's see that. Let's see that. How the data looks. It still will take time. Some time it will take. Let's see. Let's come back here. Yes, this is how your data sets will look like. You see this. So we have a demo stage. Data is there in the stage. File format FF. This entire expression I have taken as an alias called T with the help of T and $sign. T.$1 colon. I have taught this in lecture number 39 and 40. Kindly go and have a look. Lecture number 40, nested XML, and lecture number 39, destination. Then only you'll be able to understand. So exact name you have to give it. See this. Column 2, how does it look? Column 2, how does it look? Right? How does the column 2 looks? See this. Column 2, how does it look? Right? Column 2 looks as it is. Underscore column colon 2. The similar fashion, you have to write it here. T.$1 column 3, T.$1 column 4, T.$1 column 5. Now I'm extracting all these data which was in the form of JSON one by one into this column, right? Just to have it. Now what is this? Double quote is there. I have to remove this double quote. It's done. Look, I want to call column 2 as first name, column 3 as second name, column 4 as email ID, column 5 as gender, column 8 as a country, and column 11 as designation. So how many columns I need? Suppose this is the KPI which client wanted. Anand, extract first name, last name, email ID, gender, and country, and what is the designation? So 1, 2, 3, 4, 5, 6. Total 6 columns, suppose I want. Total 6 columns, suppose I want. So 6 columns, I will be defining my table. I will be defining my table, right? First name, last name, email, gender, country, designation. So once this has been defined, what I will do? Nothing, copy command. So just copy into that particular table and select whatever table you want. It will get ingested into that particular table directly, right? Particular table directly. Let's see this now. Bingo, bang on. See how neat and clean the data set is. How neat and clean the data set is. Either you can use this command or either you can use the pipe features, right? When you run the ultra pipe feature, you will see only one data set is currently down sitting. Now let's ping. Now suppose client keep on pushing the data on every Sunday or every week. So you don't have to do anything. Your pipe command will automatically ingest. That's why it says auto ingest equals to true. Very, very important interview question, right? Let's now put the data. Let's put all the files now. Let's put all the files now, whichever is there. Number 2, number 3, number 4, number 5. 1 is already there. So what it will do? It will process the remaining file. It will process all the remaining. See the size of these data sets, guys. 46 KB. Your CSV will be like 47 MB. Like that. See how highly it is compressed. How highly it is compressed. Now let's see the stage. Now let's see the stage. How many data we have? Let's run the pipe. Whether the data is there in the pipe or not. Yes. 1, 2, 3, 4, 5. Right? Correct. Data is there in the pipe. Correct. Let's see the stage. Yeah, all the size there, all has been processed with the time duration. Now let's see whether we have particular data or not coming into the picture. Directly I will run select star from table. How many records do we see now? It should be 5,000, 1,000. Still no, it has not been processed. Just hold on. It takes some time in order to process this. So this is how you do it in the let's check it in the stage. Let's see it in the stage. Yeah, you have the 5K records ready. That's what I was talking about. You have the 5K records into ready, right? You have the 5K records. Previously 1K was there. Now all the data has been ingested. All the data has been ingested, right? So I'll execute this. So automatically ingestion will happen, right? Automatically ingestion will happen. And you can see all the records flowing into the picture. That's how neat and clean data you can parse in Snowflake when the file format is ORC. Lecture number 34, 35, 39, 40, and 41 is very, very important for you all. So this is how you parse, load all the data in the Snowflake target data. So now you generate this, you connect this to Power BI, connect this table to Power BI, and do whatever KPI you want, right? So all this is how things works in the industry, right? Entire everything, all the document is there in the lecture number 41 in the Snowflake. If you go to the GitHub, all this description, link for this I have given in the description of this live video, right? So that's all. I told you it will be a very, very quick session, half an hour, because already lecture 34, 39, 40, we have discussed all those things. So go ahead and work on this, and this will definitely make you understand whenever you are dealing with any of these Parquet, AVRO, ORC, all these files format data, it will really, really help you. Now, ORC comes only when you have, most of the time you read the data. Just now what I did, I read the data. I didn't do any transformation. I just read the data. Anytime client will be uploading in the S3 bucket, you will be able to see that data sets, right? That was all from my side. Now, last before leaving, those who wants to start the analytics career, if still you have not started, go ahead with the job guarantee program in data analytics. This is the one-shot program for you all. Trust me, have trust. You will see where I'll make you land. Your entire experience, irrespective of your background, doesn't matter. If you are here to learn, I'll make you a very, very efficient data analyst in the next 8 months down the line. So if you want a career, the only one career, even if you're suggesting to the anyone, irrespective of background, if you have a zeal, if you have a passion to learn, right, and succeed, only one technology, only one domain currently which is booming and which will be thriving further down the line is data analytics. None other than that. And anyone with a basic graduation can enter into this field. I'm telling you from my experience. Right? I'm telling you from my experience. So yes, if you want to enroll in Master Data Analytics program, go ahead and enroll. The rest, I leave it to you. Okay? That's all from my side. If anyone has any doubt, feel free to post it in the chat. Let me know how did you like this session, and I'll see you soon. Till then, keep learning, keep sharing your love. Do subscribe to Analytics Channel channel if you have not done so, and let's transform your analytics learning. Happy learning. Bye-bye. Good night. Take care. See you soon.